Okay, so we are going to start now with this session. We're going to discuss logarithms. Okay, so that's our discussion for this session, logarithms. All right, I'll start with the definition of logarithms. So define them, look at the properties, and we'll look at some examples, some exercises. Okay, so this is part of the revision. So this is still revision for us. We haven't started yet on this this year's work. So this is just still revision. So this is logarithms. This is logarithms. So let me write down as a heading here, logarithms. Okay. Logarithms. So that's our heading, logarithms. Now, let's define them first. What is the log? Okay. So we say for x that is bigger than 0, a that is bigger than 0, and a that is not equal to 1. So for x that's bigger than 0, a that's bigger than 0, and a mustn't be 1, we have that y is equal to log a x, if and only if. Okay, so for x that is bigger than 0, a that's bigger than 0, and a that is not equal to 1, y is equal to log ax if and only if a to the power of y is equal to x. So y is equal to log ax if and only if a to the y is equal to x. So that's how we define it, okay? Meaning that if you have y is equal to log ax, then you have a to the y is equal to x, okay? Now, where a is called, the base of the log. A is called the base of the log. Okay, so for x is bigger than 0, a is bigger than 0, and a is not equal to 1, y is equal to log ax if and only if a to the y is equal to x, where a is called the base of the log. Okay, so that's the definition of a log. So on the left side here, you've got a log. On the right side, you've got an exponential expression, an exponent. Okay, so this is how a log is defined. It's defined using the exponential or the exponent. All right. Okay, let's move on to the next point. Let's move on to the next point here. Okay. Now, logs with a base 10. Okay. Logs with base 10. Logs with base 10 are called common logs. Logs with base 10 are called, okay, logs with base 10 are called common logs. All right. Logs with base 10 are called common logs. Okay. Logs with base 10 are called common logs. All right. I.e., y is equal to log 10 of x. That's a common log because it's got base 10. You can also write a common log as follows. You can write it as log x. So you can also write a common log as log x. Okay, y is equal to log 10x. That's equal to log x as well. So whenever you see a log without a base written on it, that means that it's a common log and its base is 10. Next point. Next point. We have we also have the natural logs. We also have the natural logs. The natural logarithm takes the following form. Okay, the natural logarithm, takes the following form. Okay, the natural logarithm takes the following form. The natural logarithm takes the following form. The natural logarithm takes the following form. Y is equal to log E x. So you can see that the natural logarithm has base E. Okay, it takes the following form. Y is equal to log ex. It's got base E, where E is the number, the constant E that you find in your calculator. So E is the constant E that you find in your calculator. It's an important constant in maths, so it has its own special letter, it's E. It is an irrational number, okay? And it's called E. So a logarithm with a base E is a natural logarithm, and it takes this form. Y is equal to log ex. You can also write this as ln x. So you can also write this as ln x. So whenever you see ln x, that is just this. It's a log with base E. Okay? Whenever you see ln x, it is just a log with base E. Okay? So now let's discuss the properties now. All right? Let's discuss the properties of logs. The properties of logs the properties of logs. The properties of logs. These properties also apply, of course, to natural logs. The ln. So ln also, it also applies to ln. Okay, so this also applies to natural logs. Okay, also applies. This also applies to natural, also applies to ln, basically. It also applies to natural logs. So this also applies to ln. So number one, okay? Now I'm going to write these properties using common logs. Otherwise, they apply to all logs of all bases. So don't get confused by that. I'm going to use common logs to write these laws, but they also apply to all logs of all bases. Okay? So let me start with the first property, number one. Log of A multiplied by B is equal to log of A plus log of B. Okay, so log of A times B is equal to log of A plus log of B. Log of A times B is equal to log of A plus log of B. That's the first property. Second property, log of A divided by B is equal to log of A minus log of B. Okay? Log of A times B is equal to log of A plus log of B. Number two, log of A divided by B is equal to log of A minus log of B. Okay? Again, log of A to the power of n is equal to n multiplied by log of A. Okay? Number four, log of A with a base A is equal to 1. Number 5, log of 1 is equal to 0. Number 6, log of A with a base B is equal to log of A divided by log of B. Okay, so log of A with a base B is equal to log of A over log of B. All right, so as I said, these properties, I wrote these properties using common logs, but they apply to logs of any base. All right, okay. Now we're going to move on to exercises. We're now going to move on to exercises. Okay. Now, I've already posted on the group page. I posted on the group page the notes on logs, which we are discussing now. So I've posted on the group page the notes on logs. And on those notes, you'll find exercises there. These exercises are for practice. So you do them to practice. So you'll find those exercises on the notes for logs that I sent you, that I posted on the group page. So you should have got those from your class representatives. So now we're going to start working on those exercises. So we'll do a couple together, and then you guys will do the rest by yourselves. As I said on the group page to your class representatives, this week we won't have any tutorials. So this week we're not going to have tutorial sessions. We're going to have a tutorial session next week where we are going to discuss exponents and logs. We're going to solve problems. During the tutorial session, we're going to discuss exercises on exponents and logs. That's next week. Okay? So for now, for this session, we are going to do, for the remainder of this session, we are going to do a couple of exercises on that set of exercises I posted for you on WhatsApp. And then you guys will do the rest on your own as practice. And you will do that before I see you for the second time this week, which is on Thursday. So on Thursday, I'll see you guys in person. So do watch this session and do these exercises, work on these exercises before I even see you on Thursday this week. Because on Thursday this week, we are going to start with a new section, which is trigonometry. So on Thursday this week, we're starting with a new section, that's trigonometry. Okay, so let's go ahead then and work on these exercises. Let's go to the next page. So we say exercises. Okay. Exercises. Okay, we say exercises. We start with the first one, first exercise. The first exercise, we are given an expression. W is equal to RT multiplied by ln of V over V0. So that's what they give us there in the first exercise. We've got W is equal to RT multiplied by ln of V divided by V0. So W is equal to RT multiplied by ln of V over V0. They give us that expression. And then they ask us to make V the subject of the formula. So we have to solve for v. So now we're going to use the properties of logarithms, and we're also going to use the properties of exponents if we have to, because we know the properties of exponents as well. We've discussed the properties of exponents, and we've just discussed the properties of logarithms. So we have those tools at our disposal, and we can use them. So now let's go ahead then and solve for v. The first thing we do is we divide both sides by RT. Okay, so we have to divide both sides by RT. So we divide the left side by RT and divide the right side by RT. And on the right, then we're going to have W divided by RT. So on the left-hand side, we are going to have W divided by RT. On the right-hand side, we have just ln of V divided by V0. Okay, so we divide both sides by RT. On the left, we will have W over RT. On the right, we will have ln of V over V0, because the RT on the right canceled with the RT that we divided by. So now we have this. Okay, now the next thing is for us to use the definition that we've already discussed, which is the definition of logs. Remember what we said about logs. Okay, remember the definition we used for logs. The definition that we used for logs is the following definition. We said y is equal to log ax if and only if a to the y is equal to x. So this is the definition that we used. And we said that this definition also applies to the natural logarithms. Remember what the natural logarithm is. A natural logarithm takes this form here. Y is equal to log e of x. So it's a log with a base e. A natural logarithm is a log with a base e. And the same definition applies to that. So this is if and only if e, because now our base is e, not a, our base is now e. So e of y is equal to x. Okay, so same definition. E of y is equal to x. Let me correct this. This is supposed to be x here. So you see, it's the same definition that also applies for natural logarithms. And we did say, of course, that y is equal to log ex is the same as ln x. So y is equal to log ex is the same as ln x. So the natural logarithm, you can write it in two ways. You can either write it as this, or you can write it as this. It's the same thing. Okay, if you look at the problem that we have here, that we are busy solving, they wrote it as ln. They wrote it as ln. Okay, so now to solve this problem, we can write the ln. We can write it as log e. We can write it in this form here. And the reason why we do that is because we want to apply this definition here in order to solve the problem that we're dealing with. So let's go ahead and do that. So we're going to write the same expression or the same equation in the following way. W over RT is equal to log E of V over V0. So we write it in this form. The reason that we write it in this form is for us to go ahead and apply this definition here to solve this problem. Okay, so let's go ahead and solve this problem. So now that we wrote it in this form that we currently have it in, we can now go ahead and say this implies the following. Using this definition here, we can now say this implies that E, so what we have so far, we've got W over RT is equal to log E of V over V0. So that implies, by this definition, that implies that E of, in this definition, we have E of y is equal to x. Okay, we have E of y. We have that y is equal to log ex, implies that E of y is equal to ex. I'm sorry, E of y is equal to x. I'll say that again. In this definition, we have y is equal to log ex, implies that E of y is equal to x. In this case, we don't have y's and x's, but we do have w over rt and v over v0. So in this case, our y is w over rt. Okay, so meaning that by the definition, we have that E of w over rt is equal to, we don't have an x, but we do have a v over v0. So E to the power of w over rt is equal to v over v0. So this is solving this expression or solving this equation using this definition here. That's how we use this definition to solve this equation. We say that w over rt is equal to log E of v over v0 implies that E to the power of w over rt is equal to v over v0. So in this case, applying this definition that we have here, we have that w over rt acts in place of y, and v over v0 acts in place of x. So therefore, we have E to the power w over rt is equal to v over v0. So now we can just simply multiply throughout this expression here by v0 in order to solve for v, because the task was to solve for v, was to write v as the subject of the formula. So then our next step is to multiply. We're going to multiply both sides by v0. Okay, so let's go ahead and do that. So let's go to the next page. So in the next page, we go v0 multiplied by e to the w over rt is equal to v0. So we're multiplying v0 throughout the equation. So on the left, we've got v0 times e to the w over rt is equal to, and on the right side, we have v0 times v over v0. So on the left-hand side, we just have v0 multiplied by e to the w over rt. On the right-hand side, the v0s, they cancel out, and we just have v. So v is equal to v0 times by e to the power of w over rt. So that's what we have. That's our solution. That's our answer. Okay. So now we're going to move on to the next problem, which is number 2. So we'll do number 2 together and then see what we get when we do that. In number 2, they give us an expression again. They give us an expression. Let me write this expression down, okay? So this is number 2. On the same set of exercises, this is number 2. So here they give us an expression. They say T2 divided by T1 is equal to e to the power of mu multiplied by beta. Okay, and then they give us the following quantities. They say that T1 is equal to 20 newtons. And they say that T2 is equal to 1,000 newtons. And they say that beta is equal to 3 radians. Okay, so if you look closely there at the problem description, they say that T1 is 20 newtons, T2 is 1,000 newtons, beta is 3 radians. And they ask us to solve for mu. They ask us to solve for mu. So they gave us T2, T1, and beta, Now we have to find mu. So let's go ahead and find mu. Okay, let's go ahead and find mu. Now over here, you can go ahead and substitute what they've given us already before you even start solving for mu, if you want to do that. Or you can go ahead and start by solving for mu first before you substitute the given values. Okay, so I would say let's quickly solve for mu before we substitute. Let's quickly solve for mu before we substitute. How are you going to solve for mu? To solve for mu, you are going to use the same definition that we used in the previous exercise or in the previous problem in number 1. Use the same definition that we used in number 1. And the definition states this. Now, this is an exponential function on the right-hand side. So we are going to use the natural logarithm here. And the definition states this. I'm going to write it down again. Or we can go to the previous page to look at it. Let's go to the previous page to look at this. Here's the definition here. I've underlined it here. The definition is this. Y is equal to log EX if and only if EY is equal to X. So same definition for the natural logarithm. Y is equal to log EX if and only if e to the power y is equal to X. So we can use this definition to solve the problem that we have. So the problem that they give us is in the exponential form. It's in this form here. So now we're going to use this definition to write it in this form here. Okay, we know that this form implies this form. So therefore, using that, using that, we say the following. Using that, we say the following. We say this implies that in this case, the mu beta acts as y, and the T2 over Ty acts as X. Okay, the mu beta acts as y, and the T2 over Ty acts as X. Let me write this thing down here again. So we've got y is equal to log E of X if and only if E of Y is equal to X. That's our definition. And I'll say it again. In this problem, the mu beta here acts as Y, and the T2 over T1 acts as X. So when we go from this expression to this expression, when we go from the exponential expression to the logarithmic expression, we keep that in mind. So we're gonna say this. This implies the following. So it implies that mu beta, okay, which acts as y, so mu beta is equal to log E of now the T2 over Ty, which acts as X. Okay, so when we go from this expression at the top, which is the exponential expression, to the logarithmic expression, using the definition, we note that the mu beta acts as y, and the T2 over T1 acts as X. So therefore, T2 over T1 is equal to e to the power mu multiplied by beta, implies that mu beta is equal to log E of T2 over T1. Mu beta is equal to log E of T2 over T1. Okay? All right? And remember, we are solving for mu. So then the next step will be to divide both sides by beta. So we can isolate mu on the left. So therefore, dividing both sides by beta will cancel out beta on the left. And on the right, we'll have 1 over beta. multiplied by log E of T1, of T2 over T1. All right. So now that we've solved for mu, we can then go ahead and substitute the given quantities. So then this equals to the following. This equals to 1 over beta. Now beta is given by 3 radians. So in place of beta, we put 3. And we multiply this by log E of the following. In place of T2, we put 1,000. And we don't put the units. That's not necessary. So we leave out the n. Just put 1,000. And at the bottom of T2 is T1. And in place of T1, we put 20. Again, leave out the newtons. Okay? If you're substituting into a function, don't put the units in there. So now we have this. And this is mu. This is our solution. You can simplify it, okay, because it simplifies to be 1 over 3 multiplied by log E of 50. 1,000 divided by 20 works out to be 50. 1,000 divided by 20 works out to be 50. So this is 50 over here. You can leave it like this because that's the answer. But if you want, you can write the log E as ln because it's equal to ln, same as ln. So you can write your answer as 1 over 3 multiplied by ln of 50. Okay, so that's your answer. That's mu. So mu is equal to 1 over 3 ln 50. That is the answer for that one. So we'll stop there. We'll stop there. I will leave the rest for you guys to do in your own time. And whatever you want to ask me, you can, if you have any questions, you can let me know on WhatsApp, or you can set up an appointment to see me on campus. And of course, we're going to discuss this during the tutorial next week. We'll discuss exponents and logarithms during the tutorial next week. Okay. Okay, that's it then. Thank you.